Hello everyone and welcome to this tutorial on our heterogeneous robot. In this tutorial we will be looking at SolidWorks URDF exporter plugin, and we will look at a package exported from SolidWorks. We'll add some plugins to this package, some materials and sensors. In order to build a robot that we will be working with throughout the series. First of all, we have let me refer you to the ROS wiki, where you can take a look at the URDF, the SolidWorks URDF exporter. You can see here on this page how you install it, how to use it, if you're familiar with SolidWorks. I'm in Catkin workspace now, source. I have exported a robot model from SolidWorks, and this is the package. The package contains the URDF. We'll take a look at that in a minute. It contains all the 3D meshes that are being used in order to make this robot, a launch file, and so on. So first of all, let's take a look at our URDF. It was a pretty complicated, so I did split it in regions. First of all, every link that was modeled in SolidWorks has a tag here, and it's pretty straightforward. It's automatically generated, so there is not a lot to explain all the links and the joins. And then I did split some links into separate regions. So I have laser links, which we will use to add some LiDAR sensors, and I have cam links, which we will use to add cameras and visualize the images in our viz. And that's it pretty much. So this file was automatically generated, and we will be adding some plugins and materials, but we will not do that in this file. So in this tutorial I would like to introduce you a different way of doing that. So and it makes life pretty easier, makes files simpler, easier to read, and we will create it in a minute. So let's navigate to the package and then to the URDF folder, and let's create an extra file here. Let's call it example gazebo exactro, and this file will be included in the main URDF file. So everything that we will include in this file will be called in the main URDF, and it will be parsed with the URDF spawner. So let's start by adding the XML tag, and let's add some materials. Or before doing that, why don't we run the package as it was exported from SolidWorks. So it's we didn't change anything yet. So let's go back to Catkin workspace and run catkin make and see what we have out of SolidWorks. So we will source develop and gazebo. For some reason that I still don't know, when I'm exporting models from SolidWorks, they don't have the correct orientation. And anyway, that's what we have now. It's this robot, no materials, no sensors, nothing really special. It's only the model. And let me kill gazebo here and go back to our gazebo plugin file. So let's first of all add some materials. Let's create a region. Region materials, and let me copy those materials. I've created those. So a material tag, it's really simple. You will reference the link name. So if we're talking about a wheel or an arm base or whatever it is, you will reference the link name and then a tag called material, and then you can choose the color. So gazebo / the color that you wanna assign to this robot. So let me save this file for now, and let me include it in the menu RDF file. And to do that, we'll add this line. We'll go find example URDF package, the URDF folder, and the file that we just created. So now it's included in the main URDF. And let me launch the package again. I don't think that when including or changing XML file, you don't really need to recompile the package. So there is an error in the XML file, and at Visual Studio I had to add I forgot to add the robot tag. So add the robot tag at the beginning of the file and close it, and then we can launch it again. You can see that the materials are now assigned to our robot. So I just assigned random colors to the robot, and that's it. So that's a material plugin. It's pretty simple. Next, let's add a movement or planar movement plugin, which will allow us to move the robot around using either move base or using the keyboard or a joystick or any other method. So back to Visual Studio. Let's add our new plugin, and it's called LibGazebo ROS Planner Move, and you can find documentations of Gazebo plugins online. I will leave a link in the description. Anyway, it's really simple. The robot base frame, you have to add the link name here, which is base footprint, and then specify the type of the plugin and the name of the plugin. Then you will add the command topic. Which topic are we going to be publishing commands on, and what is the name of the odometry topic. So that is also simple. Now that we have added this plugin here, we can test it. Let me clear this one and launch the example URDF again with the new plugin. Alright, that's our robot. Now that we have added a plugin, Gazebo knows that this is the base of the robot, and this link will be controlling the whole robot. We can always test that. We can go topic list. You can see that CMD val, this is the topic used to publish commands to, and there is a pretty useful node that is called the teleop twist keyboard, so you can install it. It's called teleop twist keyboard. You can find it on GitHub, install it and run it. It will publish commands on CMD val by default. So and it's pretty simple. You can use I, to move forward, S to stop, J and L to move the robot around, and with shift you can add a holonomic movement. So yes, that's it for this plugin. We can move the robot around now in Gazebo, and let's go further. Our next plugin will be a laser plugins, and it's called ROS laser, and this plugin would allow us to simulate LiDAR data. And to do that, let me terminate the Gazebo here, and we will add the laser plugin to our example Gazebo file. So it's also simple. As I have showed you before, we have two LiDAR sensors exported from SolidWorks. So we will start by adding a plugin, and we will refer to our links. So this is the first link. It's called laser 2 and laser 1. You can see them in your RDF, in the main RDF file. So it's there are two links, simple cylinders that will simulate the sensors. So they're called laser 1 and laser 2. We will refer to the link name. You can choose to change the rate, the radius, the start angle and the max angle. You can change the range of the ray, how far would the ray reach, and for more information you can always refer to Gazebo website. So in our case we have the link name, and I have set the min and max angles for each sensors. You can take a look at them here, and let me save this file and launch the package again, so you can see the laser data. Now here you can see it. It's pretty simple. They're on different heights, so the laser would not each link is on it's a really small difference. I don't think I can show it here in Gazebo, but each is on a different height, and so the laser rays would not collide and cause noise. Now the robot is able, with those two sensors, the robot is able to sense the surroundings, and this data will be used in detecting obstacles around the robot, or navigating a map or an environment, and so on. So that's it for the laser plugin. Our last plugin that we will be adding to this URDF is the Kinect, and it's called ROS Open Kinect. It's also pretty simple. So we will go back to Visual Studio. Let me try to find the documentation for those plugins. So here we are. If you go to gazebosim.org, you can take a look at the documentation, read about each plugin. For example, laser here. Each plugin is well explained. You can see the Kinect. Let me try to find it. The Kinect plugin, and everything about the plugin is pretty much explained in this website. It's really helpful to read about them. So now I copied the camera plugin or the Kinect plugin, and I'm adding it here. I did also refer to my camera link using the name, and that's it. Now let me save this one, close Visual Studio, and reset Gazebo to I will try to visualize all the data from Gazebo and all the plugins sensor. I will try to visualize that in RViz. Let me close it. It will take a minute here to close. Right, we'll start it again. So I will show the robot here. This process has that maybe the Gazebo did not shut down at first try it. Let me no. Alright, so I had to restart Gazebo, and let's set the fixed frame to base footprint. This is a representation of our robot in RViz, and I will try to show Gazebo and RViz side by side here. This is the robot, and let me visualize. If you go choose by topic and look at the topics that you can visualize, you can see, for example, the camera topic, where you can add that topic to let me add, this is the depth camera, let me add the RGB camera. Yes, from the robot's point of view, this is the cube that we just added. And let me add a sphere. So here you have it. You can visualize the plugins data in RViz, and you can use that for many applications, OpenCV, or as I mentioned, mapping and navigation, and we will look at that later in this series. So for this tutorial, that was it. We did include some plugins and added some virtual sensors that we will be using later in the series. See you in the next tutorial.